after the volume and the pressure, the third one, when angle of rotation of optically active compound is given. So if the optically active compound is given, then for an optically active compound, here the angle of rotations will be given. The formula is exactly, I can say it's like a volume formula. So here suppose let angle of rotation, we are represent rotation, this angle of rotation is r. So when r naught, that is angle of rotation at time 0, RT is angle of rotation at time t, and R infinity, angle of rotation at infinite time, like a volume only. So here I can say therefore the formula for rate constant. So therefore rate constant is equal to, that is K. The formula is 2.303 upon T log to the base 10. It will be R infinity minus R naught upon R infinity minus RT. So this is the formula for the K. Now again we have two cases here. Case 1. If R naught is not given, that is angle of rotation at 0 time is not given. If R naught is not given, then better remove R naught from the formula. So we will have K is equal to 2.303 upon T log to the base 10. The formula will changes to R naught is not given, so it is R infinity upon R infinity minus RT. And the case 2, if R infinity is not given, and if R infinity is not given, then I can say K is equal to, the formula will become 2.303 upon T. Infinity will not be considered so in a formula, so it will be R naught upon RT. So this is the third one, that is third case, when the angle of rotation is given. So if the angle of rotation is given, then we have three formula. If all three terms are given, that is R naught, R infinity and RT. If R naught is not given, then we will use this formula, and if the R infinity is not given, then we will use this formula. So for the rate constant, in addition to A naught upon AT, we are having three more formulas depending on the given terms or depending on the numerical, which type of numerical is given. If in a numerical or question, if the volume of reagent is given, then we will use that K is equal to volume formula. If the pressure of the reactant or the total pressure is given, then we will use that total pressure formula, and if the angle of rotation is given, then we will use this formula. The reaction based on the volume. The question is, the following results were obtained in the decomposition of H2O2 in the presence of iodine minus iron at 298 Kelvin. Here this is the reaction, the decomposition of H2O2, where H2O and half oxygen is obtained. Now the time in minute is given, 3, 6, 9 and infinity. The thing is to be considered or taken care is that 0 is not given here. So V0 is not given. So volume of oxygen evolved is 6.2 after 3 minutes. During the reaction, the oxygen is formed, so its amount or its volume is goes on increasing. So volume of oxygen is after 3 minutes 6.2, after 6 minutes 11.8, after 9 minutes 16.8, and after infinity it is 60.6, infinite time. So the question is, what is the rate constant if the reaction is a first order reaction? So we'll use the volume formula for calculating rate constant here. The formula is the K is equal to 2.303 upon T log to the base 10 V infinity minus V0, but V0 will not be considered because 0 time is not given. So V infinity upon V infinity minus Vt. So it is equal to 2.303 upon T, that is 3 minutes. Here the time is 3 minutes. We are considering the first data only. So time is 3 minutes log to the base 10 V infinity, that is this 60.6, it is given, upon V infinity 60.6 minus Vt. Vt, that is after time t, we consider time t, so it's a 6.2. It is equal to 3 7s are, you can say it's a 21, 2 will be left, 3 6 are 18, again 2, 3 7s are 21, log to the base 10, 60.6 upon 6 minus 2 4, and this is 54. So 60 point, this is 0.767. Then 60.6 upon 55.4, 54.4. When the log is taken for this, we get that on division it gives 1.114. And the log of 1.114, it is 0.0489. And after all, we have to calculate the rate constant. So this on multiplication gives 0.0360. This is the value of K. Unit is going to be per time, first order reaction, and the time is given in minute. So it is per minute. Now the next question, for the decomposition of ethylene oxide into methane and carbon monoxide is a first order reaction. The variation of the pressure of the reaction with the time is given below. The time 0 second and 300 at the time and the pressure is given. When the time is a 0 second, the pressure is 120. Time is a 0 second means the reaction has not started. That means the container is containing only reactant. So it is this total pressure is nothing but the pressure of reactant, and it is going to be the P naught, that is pressure at 0 time. And this is after 300 second, the pressure is 127.2. Now this pressure is because of the reactant as well as product, I can say, because after 300 seconds some of the reactant has got converted into product. So now the pressure exerted will be equal to the sum of the pressure of reactant and product. So this is the sum of both. Now we have to calculate rate constant, number 1, that is the value of K, and the number 2, the rate of reaction when the total pressure is 123 millimeter mercury. Then we have to calculate rate also. First, let us calculate the rate constant. So what things are given? The P naught is given, that is a pressure at 0 time or 0 second, and if time is 300 seconds, then pressure is 127.2 millimeter. This is the total pressure. That is the pressure of means the pressure inside the container, so total pressure. Okay, now here the reaction itself says that there is a ethylene oxide, that is C2H4O, which produces methane and carbon monoxide, CH4 plus carbon monoxide. From the reaction I can say that there are the two products are forming. and the question is based on a pressure. So we just derive a formula that if there is a if the question is based on a pressure and if there are only two product, then we use a formula K is equal to 2.303 upon T log to the base 10. It is in terms of pressure, so P naught, and if there is a 2 reactant, then in P naught minus X, which becomes 2P naught minus PT. Okay, so after that K is equal to 2.303 upon T. T time is 300 log to the base 10 P naught, it is 120 upon 120 2P naught, that is 240 minus PT is 127.2, which is equal to 2.303 upon 300 log to the base 10 120 upon, this is 0.8211. So it is equal to 2.303 upon 300. 120 upon 1128, after division it gives 1.064, whose log of this 1.064 is 0.02694. And on multiplication this gives on multiplication and division we have 2.068 into 10 raised to minus 4. Rate constant, first order reaction, so unit is going to be per time. Here the time is in seconds. Okay, so the first part is over. Now let's move to the second part. The rate of reaction when the total pressure is 123 millimeter mercury. Again the total pressure is given. It is 123 millimeter mercury now. Now the rate of reaction, we have to calculate the reaction is a first order. So I can say rate is going to be K into molar concentration of A, but it's instead of concentration, it's a pressure. So pressure of reactant after time T. Instead of P, I can write PT also. It's a pressure of reactant only. Rate of reaction depends on pressure of reactant. So here I can say it's a PT, that is reactant pressure. This is total pressure. So we have a relation again, PT is equal to P naught minus PT. So from here it is 2P naught, that is 240, again 120 double, minus PT, it's now 123, so it is going to be approximately 117. So PT is 117, so rate is equal to K into K, the value of K we have, it is 2.068 into 117 into 10 raised to minus 4. This can be written as approximately, I can say 117 into 2, that is 234 into 10 raised to minus 4. Answer is going to be slightly greater than this. Approximately is a 234 into 10 raised to minus 4. What rate? So molar per second. So this is the rate of the reaction.